So today what we will talk about is what is called as graph augmented generation. Now in our previous lectures we had seen what is called retrieval augmented generation, where we take a bunch of documents, then vectorize those documents after embedding, store them in a vector database, and then when we are given a query, we match the query against the vector database, retrieve the related chunks, and then give it to an LLM to coin the answer. Now we are looking at another kind of technique which is very popular with LLMs. It's a more recent technique than RAGs. It's called GAG, which stands for Graph Augmented Generation. Now often the question comes is when do you use GAG and when do you use RAG? Well, when there are complex relationships in your data, it's not just data per se, which is question and answer kind of thing, but there is huge amount of relationships among data where you are talking about connectivity between different entities. I would recommend you use graph augmented generation in lieu of retrieval augmented generation, because graph augmented generation brings out and captures those relationships which exist between entities. It identifies entities and it enables us to capture the relationships among entities pretty well. And if questions are asked which are related to the relationships, that is the use of the data is more to answer questions which have to do with the relationships, and relationships play a significant role in getting the data, then I would go in for GAG. If not, then RAG is always a possibility. So how do you do it? Let me just take you through how this whole GAG story works. So initially you have a bunch of documents like you have in any RAG or a GAG scenario. You have a bunch of documents which is essentially unstructured text, text. That is what it is. So it may be one document, it may be several documents. We are really not bothered how big the data is. So what we do is we transform this data using various tools, basically using an LLM, in fact an LLM transformer. So using an LLM transformer, we take this data and convert this data into its graphical representation. Now you will ask, what does the graphical representation look like? The graphical representation will look like you would have a bunch of entities which would be, let us say, student, professor, if it is about a university, a recruiter, and basically it would also bring out the kind of relationships between these people. There are names to these relationships. So these are the various relationships which would come out. So the idea is that using an LLM based transformer, I would take the documents, take the data in the documents. I wouldn't do it, the transformer would do it, convert that data, build a graph out of that data, and then this graph which is created out of that data would then be captured and stored in a graph database. So the data would be stored in some kind of a graph database. In our present instance, we are using one of the popular one called Neo4j, which is the graph database that we are using to store data. Now once the data is in the graph database, then your queries can work on this graph database. So when you write a user query, it can go to the graph database, retrieve the relevant information from the graph database, and then engage with an LLM and produce an answer. The process here is a little bit similar to the way a RAG works. Only thing is, in case of RAG, that is retrieval augmented generation, we don't have this kind of a data, we don't have this kind of a journey. What we do there is we take documents, we take unstructured text, we basically chunk the documents using a splitter, then we convert them into their embedded form and then store them in a vector database. So the data gets captured in a vector database. Here the data is captured, first converted into a graphical form, and then it is converted and stored in a graphical database or a graph database. Here, for example, in a RAG, the data would be just chunked and converted into its embedded vectors, and then they would be stored in a vector database. Here it is a graph database, and after that the user using an LLM will work either with a vector database or with a graph database. That will demonstrate subsequently. So today we are just going to demonstrate the process up till this part, and then tomorrow or in the next session we will talk about how this user querying on the graph database works and what happens after that, what do you need to do in order to make that happen. That will follow in our subsequent session. So let us get into the code for just doing this. I hope this is understood, and again we are going to talk in two series. First we are going to just talk about the gag and how this part works, and then we are going to talk about the use with a complete implementation picture.